Welcome back. Let's look at the Boolean data type. So in programming, we sometimes need to take decision statements. For example, if statements. You want to use if statements to check a value. And internally in them, we have an embedded functionality, which is a Boolean function. In other words, we have true or false values. Maybe you want to capture parameter, and if that parameter is true or false, implement a specific uh, activity. So we basically have two values, two Boolean values, and that is the true and the false. And in C, the bool type is not built in like int and char. That is why when we're looking at the built-in data types within C, we didn't look at Boolean variables. So to use the Boolean variables, we have to include a header file for bool, and the header file is shift, and we have hash include. So the header file is std bool.h. That is the header file. So calling this header file permits us to use the Boolean data type. So we can now initialize the values of bool. Remember, it only takes up two values. The values are either true or false. So we can have bool is perfect, and we assign that to maybe true. Okay. Or we could have bool is tall as our variable, and then we assign that to false. So those are the two Boolean data types that we have in C, but to use them, we must include the std bool header file. In other programming languages like Python, this is already inbuilt within Python, and we do not have to include another header file, but for C, we have to do that. So you have to know that true means 1 and false means 0. In other words, we try to print out those values. If you want to print out the values for is perfect and is tall, we have to know that if the value is true, we are going to get a 1 as a return. If the value is false, we are going to get 0. So it means that these two values that come up actually are almost like integers. So in printing them out, we use %d. If I say printf %d and I want to print the value of is perfect, let me terminate that and then build and run. We shall have, okay, we have an exception. That is because we didn't include the bracket here. Let's put that bracket. So if I now build and run, we have a 1 in our output. The reason is we printed out is perfect, and is perfect was taking a true value. So if we print out is tall was taking up a false value, and we said false is 0. So we print out is tall. Then we expect to get a 0 in our command prompt. So you see, we have a 0. But majorly, Boolean data types are not used for printing out ones and zeros. They are used in comparison statements. For example, in if statements, for example, if I print out the value of %d and I print out maybe 20 is less than or equal to 90. First of all, we know that 20 is less than 90. So, but this being an or greater than or equal to, we have an or in n of the values. If n of the parameters, if 20 is less than or it is equal to 90, then we shall have a true value. So you see, if I run this, I will have a 1 because it is true that 20 is less than 90. But if we had that 20 is greater than or equal to, first of all, 20 is not greater than 90, and 20 is not equal to 90. So if we build and run that, we expect to get a 0 in our output. This is very false. We don't have to use greater than or equal to. We can also simply have greater than. For example, 20 is not greater than 90. So if I build and run that, I expect to have 0 because it is false. It is false that 20 is greater than 9. Most of the times, they're used in if statements. For example, we can have if statement here. So this is topic for discussion. This one, maybe we have int x, and x is maybe 6. Then we have int y, taking up a value of 7. And then we have an if statement. We say that if, in the bracket, if x is greater than 7 or is greater than y, then we shall simply print f x is greater than y. Okay. So we can also have such implementation. Of course, this needs to be terminated. Let's build and run that to see the output that we have. We have no output. The reason is x is not greater than y. But if we made x less than, so for example, 6 is less than 7, and we say that x is less than y. So because this is true, x is less than y, this is going to be printed out. If it is false, it simply doesn't bring this one. So if you build and run that, you shall have x is less than y. So Boolean data type is usually used internally within decision statements. So thank you very much. Let's now look at operators.